using what we have learned now for linear equations, we need to be able to interpret some given linear equations in some real world scenarios. So you'll have a contextual question given, like 6, 7 sentences where they would have explained a situation or a related equation दी होगी. You would have to interpret what the different variables in that equation mean. Okay, so that's what you want to learn next, given our understanding of linear functions now. Okay, now we need to apply them in real world scenarios. Okay, now when we have a linear relationship between any two variables, the slope is generally going to represent the rate of change of something, right? The rate at which something is changing. So for example, if you have an equation like this, y equals 2t plus 7. Now let's say t here represents time. Generally that's going to be the case where one variable will be time. Now what does this 2 represent? 2 represents the rate of change of y with respect to t. That means for every 1 unit change in t, how much is y changing? So the gradient is going to represent the rate of change of something. Okay. And what about the y-intercept? That is going to represent some initial value. So for example, 7 in this context would represent the value of y when t is equal to 0. So that's the initial value for y. So the vertical intercept, the y-intercept, is going to represent some initial value, and the gradient is going to represent the rate of change of something, rate at which this variable on the left side is changing with respect to the variable on the right side. Okay, let's do an example. Let's say we have a function like this: v equals 240,000 minus 5,000 t. Now, this equation models the value of a home from 2006 to 2015. V represents value of a home. Okay. Now, the value will be in thousands of dollars, or just in dollars, values in dollars. And the variable that we have on the right side is t. Okay. Now, this is a linear relationship. 240,000 is the y-intercept. What's the gradient? Minus 5,000 is the gradient. Now, how do you interpret 240,000 in this context? That's the y-intercept, right? What's the interpretation of that? So it represents the initial value, right? So the model represents values from 2006 to 2015. What does this value represent, 240,000? This is the value when t is equal to 0, when time was 0, initial value. When is that? In 2006. So you would say it represents the value of the home in 2006. Is that okay? So it represents the initial value. So you should be able to interpret this from a given equation. Slope we already discussed before, right? How do you interpret a slope in this form? It represents how much y changes for every unit increase in x, right? We talked about this before. If x increases by 1 unit, how much does y change? That is what m represents, right? We talked about this in the previous topic as well. Let's apply that as well now. So again, the same model, v equals 240,000 minus 5,000 t. What's the interpretation of 5,000 in this context? What does 5,000 represent? What does 5,000 represent? Okay, raise your hands on the correct option. A, B, C, D. What about the rest of you? They're all incorrect. Zaira, it's B. Remember slope क्या represent कर रही है? We talked about this earlier. It represents the rate of something, the rate at which something is changing. So at when t is 0, what would the value of the home be? 240,000. When t is equal to 1, what would the value become? 240,000 minus 5,000, it becomes 235,000. When t is equal to 2, what does this become? 230,000. So 5,000 is basically representing the rate of decrease of that value every year. Every year, how much is the value of the house decreasing? Why decrease? Because there's a negative sign there, right? That's why it's a decrease. If there was a positive sign, we would say that's an increase. So which option best matches that understanding? The number of homes sold each year, that's irrelevant. The difference in dollars between the value of the home in 2006 and 2015? No, it represents the difference each year, not the total difference. This is also incorrect. Yearly decrease in dollars in the value of the home per square foot. Now, we are not talking about per square foot anywhere here, right? They're not talking about per square foot when they talk about the value of the home. That's the total value, right? So that's also incorrect. B represents the yearly decrease in the value of the home. And that's the correct option because that's the amount by which the value is decreasing every year. Is that okay? No problems? Okay. Now, this is a very important thing to understand as well. A lot of times, when you have equations like this given, you have to pay attention to the units. So let's say we've got this equation, 3x plus 5y equals 275. All right. Now, let's say 275 is the total amount that you have at a particular point, and you're spending that amount on purchasing two things. One is X and the other is Y. 275 is the total amount. Now, if 275 is the total amount, if that's measured in dollars, if this number is in dollars, every single term in this equation is supposed to have the same unit because you can't add or subtract different units. So if 275 is in dollars, that means 3x is also in dollars and 5y, this whole thing is also in dollars. Is that okay? Now, why is that important? Let's try to understand that using this example. So this person spent a total of $275 on X cups of regular coffee and Y cups of specialty coffee. This is the equation that represents this situation. They've given this equation. Okay. Now, what does 5 mean in this context? What does 5 mean in this context? Now, 275 is the total dollar amount that you have. Okay. That means every single term has the same unit. 5 is here in this term. 5y is a dollar amount. 5y. 5 into y is the dollar amount that you are spending on. What does y represent? Specialty coffee. 5y is the total amount that you're spending on that. Okay? Now look at the options. A, the number of cups of regular coffee she bought. We're not even talking about regular coffee here. वो तो X था, right? That's irrelevant. This is not correct. The number of cups of specialty coffee she bought. The question tells you why is the number of cups, so that's not correct either, right? The price in dollars of 1 cup of regular coffee and the price in dollars of 1 cup of specialty coffee. Now, they've actually made it very obvious here, but let's say there was another option. The price in dollars of, let's say the total price in dollars of specialty coffee. Now, in this case, it's obvious we're not talking about regular coffee, so this is not possible as well. You're only left with one option, that is D. But how do you differentiate between these two options? Price in dollars of 1 cup of coffee and the total price in dollars of specialty coffee. How do you decide which one of these would be? Any idea? When we talk about price in dollars of 1 cup of coffee, what's the unit here? Dollars per cup, right? That's the unit in D, right? What's the unit when we talk about the total price in dollars of specialty coffee? This unit is just dollars, and this is dollars per cup. Now, the unit for this whole thing is dollars. Unit for 5y, that complete thing is supposed to be dollars, because right side पे dollars है आपके पास. तो 5y इस पूरे का unit dollars होगा. So we can't have dollar as the unit of just 5, right? Because that will be dollar multiplied by cup. That would not mean anything. If you have D, that would basically mean 5 is dollar per cup, and then Y is number of cups. Cup and cup, they get cancelled, and you're left with dollar amount, and that is what it was supposed to be. Does that make sense? So sometimes you can pay attention. Now, in this case, it was a relatively simpler example. Sometimes it's not very easy to understand which option is correct. You can make use of units in that case as well. Okay? Try to understand which units would make sense in that equation. So in this case, having dollar as the unit for 5 would not make sense as compared to having dollar per cup, because in that case, dollar per cup and cup, when they're multiplied, cup would get cancelled and you would be left with dollars. Is that all right? Okay. Now, sometimes you have some combinations in linear models. Let's try to understand that using this example. Let's say you have a marketing agency that has a budget of $7,200 to print posters and brochures. The graph shows the possible combinations of posters and brochures. What's the cost of printing each poster? How do you figure this out? The total budget is $7,200. Can you figure out from the graph what the cost of printing each poster is? What does the graph represent? Number of brochures is on one axis, number of posters is on the other axis. If you were to take any random point on this graph, what would that represent? For example, this point. What does this point represent? That those $7,200 are being spent on 225 posters and 400 brochures. That's what this point represents. Make sense? Now you could have any combination on this line. You could have this combination here, whatever the number of posters is and whatever the number of brochures is. That $7,200 amount can be divided amongst these two products in any of these combinations. Now they're asking, what's the cost of printing one poster? How do you figure that out? Can we use this graph somehow to figure out the price of one poster? Yes? So we can look at this extreme case when we're only spending on posters, right? That point at the bottom there, that represents that you're spending all the amount on posters. If you're spending the whole amount on posters, how many posters are you able to print? 450. What's the total amount that you have? 7,200. What's that amount per poster? 7,200 divided by 450, and that should give you the result. You can see what that is. What's this? 16. That's the cost of each poster. You could find the cost of each brochure like this as well by using 800. 7,200 divided by 800. That will give you the cost of each brochure as well. Okay? All right. Okay, take a minute and try to figure this out. You have a function h of x. It models the maximum height of a plant with x grams of fertilizers. Using 1 additional gram of fertilizer increases the plant's height by how many inches? Now, what makes this question a bit complicated is the use of these products like fertilizer, plant's height. You have to simplify it by making sure that you clearly connect it to this equation. X grams of fertilizer. So X represents fertilizer and H represents height. Now, if you have 1 additional gram of fertilizer, how much does the height change because of that? How do you figure this out? Does this remind you of something? Using 1 additional unit of something, how much effect that has on another variable? If 1 unit increases by 1 unit, how much does that affect the other unit? Isn't that the definition of gradient? If x increases by 1 unit, how much does y change? Right? That's the interpretation of gradient, right? So if you were to convert this equation to a standard linear form, you would say this is h of x equals, if you break it down, you can say this is 4 over 5x plus 6 over 5. Can we do that? 4 over 5 is the gradient. Now, if x increases by 1 unit, how much does height change? How much does height change? If x increases by 1 unit. 4 over 5, 0.8, right? So height increases by 4 over 5 units. Or you can say 0.8 units. Does that make sense? That's the definition of the gradient, right? If you were to write this as a decimal, you would say this is h of x equals 0.8x plus 1.2. So if x increases by 1 unit, h is supposed to increase by 0.8 units, right? ठीक है? Okay. Let's consider that same equation. How many more grams of fertilizer should be used to raise the plant's height by exactly 1 inch? So now you want to increase the height by 1 inch. How much do you have to change x by? Why is everyone looking at the time? आपने अपनी मर्जी से रजिस्टर किया था ना इस कोर्स में, कि आपको फोर्स किया था किसी ने? घर वाले फोर्स तो नहीं किया था कि ये? आंसर सेम होगा. Remember what the gradient represents? Change in h over change in x. Achha, this triangle I am using for change. It represents change, right? Delta something that represents change of something. Change in h over change in x. What's that? 4 over 5, right? Now, if height changes by 1 unit, if height changes by 1 unit, how much does x change? You can use ratio here as well. Let me call this something. Let's call this p. Can we use the ratio method? This gives you 4p equal to 5, p equals 1.25. Does that make sense? In the previous case, we had 1 additional gram of fertilizer. That means, since we know that change in h over change in x, that is 4 over 5. We know that, right? If the fertilizer increases by 1 gram, that means change in x is supposed to be 1. What is your numerator going to be? That was 0.8 in that case, right? Now, in this case, change in h is supposed to be 1. So this is supposed to be 1 now. What should the denominator be so that we have the same ratio? No? How many of you understand this? Again, we can convert this equation to this form. H of x equals 4 over 5x plus 6 over 5. What does this gradient represent? Gradient represents change in y over change in x. In this case, it's the change in h over change in x, right? That is 4 over 5. That's the ratio. Now they're saying if height increases by 1 inch, that means the change in height, that means the numerator should be 1. What should be the change in fertilizer? ये denominator आपको figure out करना है. You can represent that by any letter and just find the ratio that you get from that. Right? Cross multiply and that gives you 4p equal to 5, p equal to 1.25. That's what you want. So you just use ratios like that. Okay? Okay, let's move on. Let's look at this example. A can of soda is put into a freezer. The function T models the soda's temperature m minutes after being put into the freezer. So T represents the temperature, M represents the time for which it has been in the freezer. What's the decrease in temperature for every 5 minutes in the freezer? Minus? Minus 6? Minus 6? Every 5 minutes. T equals 65 minus 6m. What does this gradient represent? For every 1 minute increase, how much does the temperature change? In every minute, temperature decreases by 6. 1 minute mein it decreases by 6. What about every 5 minutes? In 5 minutes, it will decrease by 30. But they're saying, what is the decrease in temperature? That means the negative sign is already incorporated in that word decrease. When you write down the answer, you don't write negative 30, you just write 30 there. Yeah. Yes, the math. 65 is the initial value, remember? That's the initial temperature. Then every minute, how much is the temperature changing? That's what the slope represents. If you're confused, you can try taking some values as well. T equals 0. What is that? M equals 0, sorry. M equals 0 gives you T equal to 65. M equals 1 gives you T equal to 59. M equals 5 gives you T equal to 35. So in 5 minutes, it basically goes down by 30 units. 65 is the starting value. 6 represents the rate at which it is decreasing. Is that okay? Now, since the question statement includes the word decrease in your final answer, you would not write the negative sign, you would just write 30. Okay?